Hello everyone, I'm Priyanka and I'm a part of SPF-MLAdversary and I'm here to represent my team and talk about our project MLAdversary. So for this demo today, we will delve into a world where minor alterations hold immense power, where a seemingly harmless tweak to an image can cause a machine learning model to stumble. Imagine this. A picture of a macaw with just a few pixel tweak get confidently labeled as a bookcase by the model. This manipulation, invisible to us, exposes how delicate our models are to subtle changes, compromising their reliability and accuracy. Our system has set up an image classifier trained on the MNIST fashion dataset. Users interact with this model using a web API, forming a client-server architecture, which is showcased in this diagram. The component-level diagram offers a detailed visual representation depicting the internal working and interaction within the setup. When users communicate with our machine learning model, they do so through a command line interface on their device. They send HTTP requests for tasks like image classification, and our server handles this, returning the result. However, this remote access also means we need strong security measures to protect our data and the server against attack, especially input manipulation. We have implemented a mandatory authentication process to ensure only authorized users access our model. Each user gets a unique token restricting API use solely to those with valid token. This step strengthens our system security, maintaining a trusted and controlled user base. Yet challenges abound. Deploying a web API introduces vulnerabilities such as DOS attack and the potential for malicious users to exploit our system. Our primary focus is countering FGSM attacks and creating defenses against this threat. So here we have investigated a scenario using a white box evasion attack, where an attacker can access both the model and the data. They use this access to execute an FGSM attack, manipulating data subtly to deceive the model. Well, here we have used the fast gradient sign method to generate adversarial examples, which is based on a simple classifier model, and it generates the adversarial examples by subtly altering input data to maximize the neural network's loss. Although usually unnoticeable to humans, these alterations can lead the model to misclassify the modified inputs, like shown in this screenshot. Now, our defense involves training a robust model on clean and adversarial examples. Unlike its predecessor, this model correctly identifies images previously misclassified by the FGSM attack. It illustrates how adversarial training significantly enhances our model's resilience against such attack. In this screenshot, we have the defense against DOS attack. Now we will attempt multiple image classification within a minute, triggering an error to indicate the limit has been exceeded. Now this showcases that our API limiter effectively defending against a potential DOS attack. After a minute, normal operations resume, ensuring a secure interaction with the API. So now comes a demonstration. At first, we have to just start the server, and the entire set of commands required is mentioned in the README file in our Git repository. Now once the server gets started, we will just wait onto that. Now here, once the server starts, we will first use the register command to see that whether our user exists in the system or not, and it does. And then we take a token, and once we request a token, then we just place that token in the CLI of the .env file. Under the CLI folder there is the .env file, so we place the token there. And once this token has been successfully placed, then we will continue. Now we will show how a simple model misclassifies an adversarial image due to its vulnerability to FGSM. And we will also present the same adversarial image to our robust model, and trained with adversarial samples, the model accurately classifies the image, proving its resilience. Now we will attempt multiple image classification within a minute, triggering an error to indicate the limit has been exceeded. This showcases our API limiter effectively handling and defending against the potential DOS attack. And then we have to wait for a minute. In summary, our measures against the FGSM attacks and potential threats demonstrate how a robust model, coupled with stringent security measures, can safeguard against adversarial attacks while ensuring reliable and controlled access to our machine learning model through the Web API. Thank you.